Okay, another situation that we can use substitution to solve systems is in nonlinear systems. So it doesn't always have to be two lines when we're using substitution. This is a perfect example of the type of problem where we could use substitution. We have the system y equals 3x and xy equals 48. So one of the equations is solve for y. So y equals 3x. So what I'm going to do is I'm going to take that 3x and I'm going to substitute it in for the y down here in this equation. Okay? So if I do that, I get x times 3x is equal to 48. Well, that would be 3x squared equals 48. If I solve this for x, remember if you have x squared equals 16, that means that there are two solutions, both 4 and negative 4. So to find the y values, what that tells me is that there's going to be two ordered pairs that are solutions to that system. So if I think about it graphically, there's going to be 2 points of intersection between that line and that curve. So if I do that, if I plug my x values in for y, I have to plug both of them in. So 3 times 4 is 12. That would be one of my y values. And the other one is 3 times negative 4, which is negative 12. Now, all of those four numbers are not interchangeable. 4 and 12 are paired together, though, so that's my ordered pair. And negative 4 and negative 12 are paired together, so that would be my second ordered pair. So this right here would be my solution set for this system. Alright, the last idea I'd like to take a look at here is the idea of consistent and inconsistent systems. Basically almost all of I think all of the systems that we've looked at so far have been consistent systems, because all a consistent system is a system that has one or more solutions. So if you think about all the examples we've just done here, 1 through 3, all of them have at least one solution, therefore they would be considered consistent. Example 4 in your book, okay, in which you might want to reread that one, but that also is considered a consistent system. The idea of an inconsistent system then would be any system that has no solutions. Okay? Okay, let's look at example 4 here then. It says solve the system x equals 3 minus 2y and 3x plus 6y equals 6. So once again, it works out really nicely for substitution because I can substitute what x is equal to in for x in this bottom equation. So that's what I'm doing over here. And as I do that, and I go through and I do my solving, I end up with 9 minus 6y plus 6y equals 6. Well, it turns out that my y terms cancel out and I'm left with the statement 9 equals 6. Well, that's a false statement, okay? And any time in the process of solving a system, if you end up with a false statement like that, that means there's no solutions and it is an inconsistent system.